As an Android developer, you're no stranger to writing asynchronous and concurrent code in order to keep your app snappy and responsive, and your users happy. We're talking about handling things like reacting to button taps and when the keyboard will be shown or hidden, downloading data, processing images such as to apply filters or do resizing and cropping, saving data to disk, and playing audio and video media. Some might say pulling it all off correctly might feel a bit like pulling a rabbit out of a hat. The Android SDK provides various dissimilar APIs to do this work, including threads, runnables, async tasks, and work manager. It's a bit of a soup of various APIs and patterns really. And this is really where RxKotlin comes in. It allows you to write declarative, asynchronous, and concurrent code that embraces some great aspects of functional and reactive programming, based on consistent patterns and operators, which, remember, adhere to the Rx standard shared across multiple languages and platforms. RxKotlin helps to avoid unexpected side effects by properly handling mutable state. And it enables writing code in a succinct and compositional way that is also much easier to reason about later than traditional imperative approaches. And RxKotlin APIs are designed to promote best practices like code isolation, decoupling, and reusability. Oh, and Rx is multi-platform, so your skills are portable and cross-platform collaboration is greatly improved. So those are some good reasons to learn RxKotlin. Some reasons why it might not be a good time for you to learn RxKotlin include, first, it lives up to its reputation of having a relatively steep learning curve in order to become an expert at it. It's a bit of a paradigm shift going from traditional to reactive programming. So if you're on a tight deadline, now's probably not the best time to tackle learning RxKotlin to incorporate it into your project. As we said in the introduction, RxKotlin is actually Kotlin extensions around RxJava. When working in Android, you also will pull in the RxAndroid dependency that adds some Android-specific items. There are other libraries you may want to use, like RxBinding. Each one of these is another dependency for your project. RxKotlin and the most popular Rx community libraries are actively maintained and developed, but you're still adding a bunch of dependencies into your project. RxJava and RxKotlin are definitely growing in popularity and adoption, but you could still find plenty of development teams that aren't using them, yet anyway. So while it's not an all or nothing thing, you would not want to start using RxKotlin in a project where all the other developers are not interested to learn it too, at least to some reasonable extent so that they understand your code. Which brings me to my next point. RxKotlin gives you near superhuman powers as a developer. Well, that's a bit of a stretch, but it does let you do some very powerful things with very little code. Use it without understanding what you're doing, and you could get yourself into trouble. But that's why you're here, right? To get started on the best foot possible. And I guess one other point I want to make here is, it's not a panacea. It's a collection of some very fine tools, but they're definitely not the only ones you'll want in your toolbox. Now, all that being said, RxKotlin, really ReactiveX overall, is based on two primary patterns, Observable and Observer, which are also sometimes called Publisher and Subscriber. You're going to create observable sequences and observe them in a reactive manner, a lot. The primary base type in RxKotlin is Observable. It's a typed sequence that can emit 0 or more elements, such as integers, over time to subscribers. Actually, an observable won't emit anything unless it has at least one subscriber. Here's a marble diagram of an observable of integers, but these could also be taps or other recognized gestures. Just remember that an observable is typed, so you wouldn't have an observable that emits integers and taps, for example. So, every time an observable emits a new element, subscribers will have an opportunity to do something with that value or react to that event in some other way, such as to display an alert or something. The vertical bar represents the end of the line for the observable. It is terminated at that point and cannot emit any more elements. So let me explain that a little better. An observable can emit a next event containing an element of the observable type. And when the observable is done, it emits a completed event. This is considered normal termination. However, sometimes things can go wrong, and when that happens, an observable will emit an error event. This also terminates the observable. An observable can only emit one error event and it's done, and can no longer emit any more events. just like when it emits a completed event. So to recap, observables can emit next events containing elements with values of the observable type. And observables are terminated when they emit either an error event or a completed event. And with that little bit of theory, you are ready to get started with RxKotlin. On to the next video.